Ja, og så er vi klar til dagens næste taler, og det er Martha Lewis. Kom herop. Værsgo. Du er jo Head of Materials på Henning Larsen hos Henning Larsen Architects, og har været i gang med en stor og meget grundig kortlægning af materialer og deres sundhedsmæssige egenskaber. Og det er noget af det, du skal fortælle om nu, og du vil holde din speak på engelsk, og vi vil bagefter gøre plads til, der er tid til spørgsmål og kommentarer på Marthas oplæg. Men værsgo. Tak skal du.
Lisbeth. Ja, som sagt vil jeg holde det på engelsk, men spørgsmålet er meget velkommen på dansk. Jeg foretrækker, når jeg præsenterer, at være på engelsk. Så vi snakker. Today we're going to talk about materials, health, and the very important future. There's been a lot of writing regarding the various connections at the intersection of humanity and the natural environment. The analysis is primarily from 4 research fields, from evolutionary biology, from social economics, evolutionary psychology, and environmentalism. Through drawing on these different fields of knowledge, a deeper understanding is brought to the growing issue of humanity's relationship with nature and its impact on health. It is clear that there is a complex interrelation between human beings and nature, and it's also clear that impacts from the building industry are currently out of kilter with different ecosystems. So when I use the word health, I am talking about planetary health, as well as health of individuals in the buildings we create, as well as the health of the people who are involved in all the phases through the building chain. On the material level, this means that environmental impacts are of preeminent importance, as well as the off-gassing of materials, as well as the chemical content of materials. All of this has an impact on human health. And most likely, it's clear to everyone in the room that our business as usual is in conflict with planetary health. That CO2 levels have grown to crisis levels, and that active strategies are essential for reducing this devastating impact. That the natural systems are at a dangerous tipping point. Not only do we have to stop introducing more CO2 into the atmosphere, we need to absorb existing CO2 from the atmosphere. Something that trees are quite capable of. We are also dependent on human innovation. This is a rendering. This is in the works. This is the systems that are going to be needed in order to pull CO2 out of the atmosphere, that will fill deserts in order to pull CO2 out of the atmosphere. We don't have it yet. There are certain companies that are working on very interesting innovations. However, what we do have now are forests, and we have trees, and we have the possibility in the building industry to use wood in our building projects and sequester the carbon longer into the building's life. This is a project Henning Larsen has in Sweden that's on the drawing boards right now, and where we're having a very interesting collaboration with a Swiss company and with a Swedish contractor. Another project that's on the drawing boards right now in Germany, a huge complex where we have done the master planning and are now working on the first phase. Again, working with a CLT system. I'm going to run through the motivating drive for why we really should be more cautious about what materials we're choosing and how we're making our buildings. I promise you that there are only maybe 1 or 2 of these statistics that you've seen before, and that the rest will be new. Most likely have seen this one. This is international data that came out from the World Green Building Council last year, that the construction material industry is responsible for 11% of CO2 emissions. This is a serious issue, but it's also a wonderful possibility for us to address this crisis. Another serious challenge we're facing right now is that the level of chemical usage in industry has risen. The UN report from 2019 indicated that the UN goals for reducing chemicals usage would not be able to be met for 2020. And not only that, but in this 600-page report, the prognosis was grim, that the chemical use is expected to double between now and 2030. And why is this relevant for us? It's highly relevant for the building industry because the construction sector consumes 28% of global chemical production. This is larger than any other market. The construction industry is the largest end user, whether you look at volume of chemicals or whether you look at revenue. It's much larger than almost 4 times larger than the agriculture sector, and also larger than pharmaceuticals. So there's also great potential for improvement here. If we look at Denmark, because I'm often challenged with, but in Denmark everything is just A-okay. If you look at the statistics from Denmark and look very specifically at the building industry, there was a Mimichondrion report from 2016 that took a look at the data from 2012, and this indicated that there were 14,000 tons of hazardous substances in use in Danish building products. And this is a combination of substances of very high concern from the REACH lists, as well as the Mimichondrion's own list, which I know is now retired, but the chemicals are nonetheless still problematic. So their report looked at both the loose substances and the REACH substances. I did an update of that report in 2006 and in 2018, grabbing 2016 data. There's always a data lag here. And this 2016 data did not look very positive. This is showing that the same list of chemicals, the usage has increased to 22,500 tons. This is a lot of problematic substances. And again, these are the substances that have been listed by the EU or by Denmark as the most hazardous substances, the substances that are carcinogenic or reprotoxic, mutagenic, or highly hazardous to the environment. In this report, the conclusion was that there are 48 different hazardous chemicals that are used in Danish building products. And that of these 48, 24 of these substances are problematic at the end of life phase. This is really important information if we're all standing around talking about a circular economy, because if we want to reuse products, we need to be certain that we are not carrying problems into the future. And these 24 substances, if we want to reuse products, also make that reuse, that screening, that environmental screening, much more expensive for clients who have these substances in products in their buildings. Another potentially little known fact is that the construction sector consumes 19.7% of the plastics used in the EU. This is the making construction sector the number 2 end market. Packaging is the number 1 end market at 39%. This one you all know. This is the ambitions of the government, the Danish government, to reduce 70% of the greenhouse gases in 2030. So what we need to do in the next 10 years is extraordinarily pertinent. I bring this up, you all know it, because it's so important, but also because it has a very interesting overlap with the sector I just mentioned, the chemical industry, because the chemical industry is responsible for 7% of greenhouse gases. And there is an interesting overlap with the building industry because of that 7%, 75% is composed of only 18 heavy CO2 emission products. And in these 18, 4 of them are used in building products, benzene, ethylene, propylene, and menthol. So the prognosis for these 18 substances is that they're going to double in prevalence by 2030, and that by 2050, we'll have a 200% increase. So the tendencies that are happening in the sector are directly in opposition to the ambitions of the UN and the ambitions the UN has for human and planetary health. So just a short summary of where we are. It's not looking so good, but again, we have a lot of potential for improvement. The material decisions we make now are critical. We need to be better informed about the choices that we are making and the products we're selecting. So if I just do a quick summary, we need to get the CO2 down. We need to be choosing materials in the planning process, putting them into the specifications that are lower in their CO2 emissions in the production phase. We need to be keeping a good eye on chemical content, and we need to be working as designers with design for disassembly so that there is a potential for reuse. I have 3 different cases from the office. And this is a case that is actually a cross-sector initiative together in the Forum of Sustainable Build in 2016. I was on a task force that looked very specifically at traceability and transparency in building documentation, building product documentation. And this was together with NCC, and with some manufacturers, with Cradle to Cradle, also with Tarkett, with Danske Brandsikringsinstitut, and some. Sorry. Am I on? Okay, good. And the initiative was to look at how can we create documentation or work with existing documentation and expand that in order to establish information where on an article level, on a gypsum wallboard or on wood, on lumber, how can you get material information about chemical content and about potential for circularity? It is nothing more complex than what we already have in the food industry. You have the nutrition labels that indicate what are the contents and what is the ranking of the contents from largest to smallest ingredient. And you also have the E substances listed. If there's some problematic substances, perhaps you're allergic to some of the preservatives, you can keep an eye on this when you're buying bread. You also get a good calorie division and fat. You just get good and useful information for your body for when you buy food. And we're looking for a similar declaration for materials. So do I have sound? Okay. The material pass is to encourage transparency, but also traceability, so that this is a material pass that would then live in a digital building pass, so that a client would have a vast information base for in 50 years when they want to either tear down the building, or maybe even 10 years when they need to redo a division and rebuild and do internal renovations. Then they have a much clearer understanding of what's in my building. Is there any value in my building? Can I resell some of that copper? How much copper do I have? If there are hazardous substances, they'll have more knowledge about that. Are there some hazardous waste processes that need to happen in the demolition phase? So this is thought of as a material pass that has traceability over the lifetime of the building, and that it could, on a building pass level, register changes that happen. If new windows are exchanged, replaced, then a new material pass will come into this compilation building pass. that's the driving idea. The initiative is also working as EU-oriented as possible, because there is no winning situation when we work only locally on a national level. So we're working together with Danish Standard, who are following our process and are eager to write a Danish standard that would then be written in English and be ready to move wider to the EU market. What's in this material pass? Chemical content, other content, and very specific information regarding circularity. How do you take the article out of a building? How do you, if it's a complex article, a component, how do you break it into different parts in order to utilize resources and to be able to reuse directly or recycle or set it into new production processes? Simply more information about that. Is there a take-back agreement with the manufacturer? That would also be listed here. The material pass would be a possibility for collecting links to existing documentation, for example, EPDs with environmental information, or to other certifications, off-gassing or Svanemærkning. And I want to underscore that this is a voluntary declaration, that it's a very conservative industry, the building industry. And we need to start off on a voluntary level. I, of course, would love to see this as a requirement, but that's not the way to start. The way to start is with the people who actually see that this could help their product and give them a very good business case if they worked with transparency, if they embraced transparency. We're looking at a uniform format so that any consultant, any DGNB auditor could pick it up and say, okay, I know on page 5 I could find that information about formaldehyde, or I can find that information about HBCDD. It needs to be digital and not just in PDF form. And at the moment we have a consortium set together that includes Danske Byggecenter. And Danske Byggecenter has been working on a documentation platform called bygdoc.dk. And this website is their platform for their members, which they have just made public. So anyone has the access to look at what's inside of the platform. And at the moment, it contains the existing documentation, for example, CE-mærkning or EPD, safety data sheet, technical product data sheet. And they are very eager to have a material pass to add to the collection on this platform. So we're in a development period. We're very encouraged that the Klimapartnerskabsanbefalinger to the government, these climate partnership recommendations, included the recommendation that we need to establish a material pass along with reducing CO2 in construction, and that the material pass will then support a circular economy and encourage reuse and make it easier for products to be reused if they are documented. As I said, right now we're in a development phase. We have, in June, we won a yeah. It's a little shaky. Am I standing on the wrong cables, maybe? Yeah. Okay, in June we won a project from TBBST, and we are working on, together with DTU and with Henning, Larsen and NCC and DBE, and Sonderhus from Sweden. They come with a lot of good experience, and from Sweden has been doing building declarations for 25 years. They've been involved, Sonderhus has been involved in this process. Sonderhus was also involved in a innovations Horizon 2020 project in the EU called BAMP, Buildings as Material Banks, looking at how to do a material pass. That project has ended and it has not become a commercial endeavor. So we are picking up with the good knowledge of Sonderhus's partnership in BAMP and moving forward on the Danish/EU initiative that we're working on now. So with a potential material pass on the horizon, I am looking forward to conversations with material manufacturers and representatives, sales representatives. When I say, how green is your product? That they can say back to me, well, as a matter of fact, I can tell you what is in the product, and I can tell you how much CO2 is emitted per square meter. This is not a conversation I've had yet with a manufacturer or a sales rep, and I think this is where we all need to be in order to be able to have the understanding to make the right decisions about what comes into our projects. That was the first case. In the second case, we get over to the more traditional case, the building. Looking at a school that we've done in Freeland, in Jutland, called Feldbelleskole. This is a really little project. It's a pilot project for Henning Larsen, and we are using it to test out ideas, to test out materials, to test out new partnerships. These are the responsible drivers of the project. My colleagues, Magnus, architect, and Peter, constructing architect, working together with a building product manufacturer and / contractor enabler, Lars Keller from Small Planet. They work together with him, you'll see in a minute, because of the structural system. The project itself is small but ambitious. It has a budget of 4 million, and the size of the addition to the school, an existing school, is 250 square meters. So this is not because of the square meters that we're focusing on this. This is the ideas and the developments that have come out of this. And I should note, in terms of partnerships, we have Real Dania funding this part of this initiative. The project itself is, as I said, an addition with 2 classrooms and a flexible social space in between, and of course the connection to the existing school. It's out in the country near Freeland. Small addition because the number of pupils in the school have grown. And we're working as much as possible with bio-based materials, with a very clear eye on reducing the CO2 impact of this project in the production phase. So we have Eco Cocoon is the name of the product that is the structural system. It is a small building. It is 1 story high. Eco Cocoon works also in 2 stories without extra structural support. But you can see it in the upper left corner there, and I have many more pictures from the site. As much as possible, we're working with wood fiber-based insulation, and except where we're in contact with earth, working with a wind sheathing that is an asphalt wood-based product from Hunton. Cladding is untreated spruce, and the windows are wood windows. I'm not certain which wood windows. Clay rendering on the inside. Ceiling panels that are wood cement boards, and a wooden flooring. At the same time, I mentioned we were working on this as a potential for developing ideas and for working out 5 very specific dogmas in order to set a standard for a healthy, sustainable, or healthier, I should say, sustainable building. The first one is reduce that CO2, use biomass, sequester your carbon, and make certain that when you do that, that you work with the future in mind, that you are working with design for disassembly, so that you can unscrew those structural elements and reuse them. If they're in a good condition, if they are able to, if you can take them apart and transport them to somewhere else, this is an ideal situation. So a lot of the details were worked with mechanical connections in mind. The flooring, for example, is not glued into place. It's a mechanical connection, old-fashioned way of doing a flooring. And then number 3 is, what are these interior materials we're taking in? And are they good or are they problematic for the indoor air climate? And so we worked with products that had either certification or had some numbers in terms of TVOCs and formaldehyde off-gassing. We have been looking closely at the materials and to the degree that it is possible. And I will not stand here and say that we're working completely free of chemicals, but where it is possible, we've made choices to reduce chemicals in the products. And the last one is reuse of local materials. There was an existing wall that had to come down, and how could these bricks be taken down and then reused in the landscaping of the addition. So right now the project, these pictures are from Monday. This was delivered on site on Monday, and in 4 hours, the truck arrived at 12, and by 4:30 they had a lot of the walls up. Not all of them, but nearly all of them. The truck was delayed by 4 hours, so it's just really a shame. They would have been able to get the whole building up had the truck not had delays. But the products are made in Lithuania and then transported by truck, hoisted with a crane onto the slab, the terrain slab. And I will say that this terrain slab we took a close look at and tried to do a raised wooden terrain slab on grade, but ended up, due to price, going with a traditional solution in concrete. So here are the elements all on top of each other and being lifted into place. There were 12 men and women working on site. 2 people can move an element if you need to move it further with the help of a dolly. Otherwise, you can move it into place as 2 people. And by the end of the day, it looked like this. So they had nearly all the walls up with the exception of, that triangle that comes in, that's called the Gowl in Danish, the triangle pediment at the ends. Yeah. And of course, the roof will, also a wooden structure will come on top of this. That's not part of the eco-cocoon system. So the building's not finished yet, but to get the structure up, with 12 people working, this is only 4 hours, and they could complete it within a day. It's exciting for a small community. My third case is Mimichondrion, which is a small building in Stockholm. It is what we would just call a leftover piece, one of these tricky sites where you actually get a lot of ideas because it's a really strange site, and it informs the design process in a very lovely way because it's a very quirky site. The client wanted a cafe or a very small building, but an iconic building that would attract attention and then have a good story and also be a nice place to take a break. So the cafe is in Stockholm. These are the sections. It's done in glulam columns and beams, and the basement is concrete. The interior is a combo of a lot of glass, and in between the glass, cork, perforated cork with wood fiber insulation behind that for absorbing acoustics. And the exterior is pine that has been burned and treated with linseed oil. The details were worked out very specifically so that they could be demountable, working with visible screws on the exterior, working with frames for the window, so that all of the connections are mechanical, working with wooden windows. Here's a section from the inside. This is in the tender process, or just coming out of the tender process now, actually. Yeah, so what to do, what to do. We have some huge challenges. We need to make making very good decisions. And my first piece of advice is simply question whether you really have to build. I know this cuts right into some bottom lines, but we need to begin to see the world with a double bottom line. We need to look at what we're earning, we need to look at revenues, and we need to look at human health, because that will ultimately be on the financial bottom line through societal impacts if we don't get a better hold of what we're doing to our ecosystems and to the humans who live in these ecosystems. The second is to renovate. You can't avoid building. Can you renovate? Can you reuse some of what you have? The middle, the blue diagram here is showing a study from our friends at Ramble, where they did an analysis of one building, looking very closely at this existing building. What if it was torn down, demolished, and an entire new structure was established with the new requirements from the client? And they totaled that process at a total of 1.6 million kilograms of CO2. If, on the other hand, you do what's shown in this circle, and that is you renovate, you take many of the finish and the fit out of the building, leave the structure. It's primarily the structure that remains, and work with renovating the project. You have simply drastically lower reduction in your carbon impact. And the difference is, with a renovation project, same building, they reduce it to 29,000 kilos. This is a difference of 56 times more CO2 if the whole building had been taken down and built new. And they are still taking out the parts of the building that need to be replaced, or the parts of the building that have come to the end of their life. So there is transport with demolition material from this project. Nevertheless, huge savings in carbon. And the other, the reuse. I think that this is perhaps Henning Larsen's greatest circularity story, is the 6 buildings that we have built since 2016 that use Gammelmorstein recycled brick. I did a tally on the CO2 footprint of those 6 buildings, and we're saving just under 1 million kilograms of carbon by using the recycled bricks rather than using new bricks. My other piece of advice is to focus on the upfront carbon. This is looking at carbon in the production phase. If you're an LCA nerd, this is the A1 to the A3 phase. We need to have an eye on what's happening now in production, whether the product lives 100 or 150 years, or the scenario at the end of the life is perhaps less critical. We will not be burning wood and letting that release into the atmosphere in 50 years. It is simply inconceivable for me that that will happen. That will be the reuse scenario. C and D are scenarios for the future. Focus on A. And this is an analysis of a CO2 footprint. This is not an LCA. This is a CO2 footprint, a review of echo cocoon. And this is a little bit bigger, maybe 300 square meters. But we looked, the green is the school built with the organic materials, and I made a fictive reference building that was built entirely with concrete, but also with block. It's a small project, so the walls wouldn't necessarily all be elements. There would be some built up with blocks. And we're trying to work as realistically as possible in making this comparison. And I don't know if you can see the 0 line. This is because this is allowed in Denmark at the moment. We will be doing calculations differently at a certain point, but today this is how we calculate carbon. So the positive is emitted and the negative characterization values are sequestered carbon. and a summary of that. This is broken down by building components. So the big one is the exterior walls where we're using Eco Cocoon. Also on the roof structure, the organic material was using more of the layers were bio-based, and the insulation was also bio-based, whereas the standard building was using a mineral insulation. The summary of the entire building, the reference building, has a little over 100 tons of CO2 emitted. And if we look at this School for Life, we are sequestering 32 tons of CO2. This makes a difference, which is why I hype biomass. I hype the possibility for sequestering carbon, and not just in the structure. We're having huge challenges, which we should meet and we should take and we should run with. But it is a slow industry to make change. In Denmark, these wood buildings, although there are many people, I was just recently at Build in Wood, 300 people, 200 people online, everyone very interested in Build in Wood in Denmark. But it's not always possible, and it meets huge challenges, and we need to keep working on that. Meanwhile, you can look at what insulation are you using, what are your cladding materials, particularly on the inside of your building? How can you increase your biomass in your building? This is an initiative from CNARC. We had a PhD, Pelle Munk-Petersen, who was an industrial PhD who was part-time in our office and then also at CNARC. And he gathered students to do this building products pyramid, where he was using EPD data and looking at 1 kilogram of a whole variety of different materials. You may have seen this, it came out for Building Green last year. Can you hear me now? Okay. This opened up a platform for a discussion, which is very interesting. I mean, we can have a long conversation about this, but I think that what is most interesting about this is that people begin, whether you're a consultant or whether you are a contractor or whether you're a manufacturer or a sales rep, that you begin to have an understanding of what your product is doing to the environment. And these are numbers. And we can talk about, okay, well, you know, you use a huge amount of this material and you don't use very much of this material at the top. Isn't that okay? We can have all those conversations, but it opens the discussion. That is the most important thing, that people begin to think about it and begin to get a feeling for those numbers, because in a few years, we're going to be much more informed about it, and we need to start now. Measure, measure, measure. Also, really important. And you don't need to be an LCA specialist to do this. You need to be able to open an environmental product declaration, and you need to be able to understand some basic information that is in the EPD. In particular, you need to look at the greenhouse warming potential, and you need to be able to look at your decisions that you're making in your building and compare them on a carbon level with other options. This is based on EPD data, and I'm working with ranges. And I found as much EPD data as possible. So I have ranges on there. All that said, perhaps you also might want to take action. Again, this is the what to do, take action, inform yourself, take a look at Danish architects declare a climate and biodiversity crisis. If you have already signed the list, find out how you can, this organization or this list of people, signatories, can be more active. And not just something that you signed and then moved on to do business as usual. How can we actually make this into real change? And keep an eye on what's happening politically, because this is a very political issue, unfortunately. Otherwise, I think it would have been solved a long time ago. This is a proposal, a citizens' initiative for a new law to increase the demands on the building sector to reduce CO2. It actually is no longer active. It reached about 930 signatures, and then it failed in the time that it had. And so keep your eye on what the younger generation is doing, because they are very active. And last but not least, if you feel like you also would like to be very active, then take a look at Extinction Rebellion. They have a very interesting collaboration going with the building sector. Some of the spearheads in the building sector are helping Extinction Rebellion be much more aware of the building sector's impact on the environment and on health. Thanks. So are there questions?
Yes, thank you very much, Martha. Thank you. It was very informing, and it was also very good to see examples of how to take action. And I'm sure that you all want to ask more questions, won't you? You're all dealing with materials when you build, or when you make buildings for new city areas. And also, if there are people looking at the live stream, and you might also have some online questions, and everyone are welcome to present them in Danish or in English, as you like. Er der nogen spørgsmål? Der var et. Yes. Vil præsentationen være liggende online? Lige nu bliver den streamet, men den kommer til at ligge online. Ja, det gør den. Godt. Den her som PDF? Ja, det gør den. Ja. Jamen tak, tusind tak. Og så om klokken 14.30 vil der være tid til den næste taler, og det er Nicoline Dyrup. Så imens kan I gå ud og kigge på udstillingerne og tage en kop kaffe.